Okay, now we're going to get into probability. It's confusing sometimes, but that's okay. It's also very useful. I know a lot of you are very confused by probability, but don't worry, we're going to try and get into it a little bit. Okay? First, I'm going to start off with the motivation, the birthday problem. In a room with 30 people, there is a 70% chance two people share the same birthday. I want you to think about that a sec. That's kind of crazy. Try that out next time you're in a room with a couple people. See if anyone has the same birthday. 70% chance. You could figure that out using probability. There's 435 conditional comparisons. With 57 people, there's a 99% chance two people share the same birthday. This is ignoring the fact July, August, September tend to be the most common birth months, but this is very interesting. A lot of probability is kind of mind-blowing when you think about it and you really work out some of these things. You go, wow, I didn't realize that was so likely. A lot of things aren't coincidences. And it makes things very, very interesting and at times very odd. But there's nothing that hard on this test, so I won't do the math behind this. But if you're interested about learning more about probability, math is fun, has more on the shared birthday problem. And something that's interesting is you may just be thinking, oh, this is an interesting math thing, but, this can't be useful. Actually, it is. The birthday attack is a very common hacking attack that's used to exploit hash collision based on probability. It's fairly likely that a number of hashes will have similar characteristics. So it makes it so that you can attack a wide range of them at once. Okay, so what is probability? Probability or chance is how likely something is to occur. Probability of independent events are not affected by previous events. Dependent events are. So taking marbles out or cards out of the deck and not replacing them, not putting them back, is an example of a dependent event. If I have 4 aces on the first hand and you're still drawing cards out of the deck, and it's a fair deck, you have a 0% chance of getting any because I have all of them. Now, independent events are something like a coin toss, where they're not affected by previous events. Every time you flip a coin, you always have the same chance, okay? So here's just some tips and tricks. Wording of the question using either or is usually additive. Like if they say pick blue or red, then you usually add the probabilities. Independent events are stuff like rolling a single die, flipping a coin, or something with replacement. Dependent probability is certain events in a row, like taking cards and things, or pick one, then the other, like marbles that are removed, but not replaced. If they're replaced, it can still be independent, but if they're not replaced, it's dependent. There's something called the Gamblers Fallacy. A lot of people have this fallacy, this false conception that something's due. You may hear someone say, play the slots. Say, oh, I'm due for a big win. Or play the lotto, I'm due. Or play a roulette wheel. Or play a hand of cards. And think that they're due. Since the probability is 50% that they're going to definitely get the thing. But the thing is, independent probability, it doesn't matter. Because if you're flipping a coin, there's a 50% chance every time. There's no waiting to eliminate bias to make sure you get a tail sometimes. That's one of the things about probability. It's not absolute. It's a chance something will happen. It's not guaranteed. When I use the letter P, it's for probability. It's the ways something can happen, the total outcomes. P goes from 0 to 1. Okay, it can also be put into a percentage. And you think the same way in terms of the decimal. So 0.3, 30% chance. 1, that's certain, 100% chance. 0, 0% chance. Okay? So what's the probability if you toss a coin, it will come up heads? It will come up tails. How about if you flip 19 times and got heads? What are the odds of heads on the 20th time? Assuming an unaltered, ungimmicked coin. What are the odds of you getting heads on 2 consecutive flips? Okay, you remember you could pause the video by pressing spacebar on a PC or by tapping your phone. or mobile device. I'll give you a moment to do that. Okay, we're back. So there's P equals 0.5. There's a 50% chance if you toss a coin, it'll come up heads or tails. If you flipped a coin 19 times and got tails, what are the odds of heads on the 20th time? 50%, assuming an unaltered coin. So it's not one of those Two-Face coins from Two-Face and Batman. Has one of those coins. He has two heads and one of the sides is scratched and he goes on a murderous rampage if it comes up the wrong side. But this is an ungimmicked coin. The thing I want to hammer home here is when we talk about independent probability, I flipped it 9 times and it came up one way. Since it's an independent probability, it doesn't matter. There's still a 50% chance on the 20th time it could come up either way. Consecutive probability is founded by multiplication. So we have the chances 50% or P equals 0.5. We multiply and we get 0.25 or 25%. That's the chance I'll turn up heads 2 times in a row. Heads, heads. This is different than what we were doing before because you want to make sure, okay, these two things both happen. So you multiply. It's not either or, okay? And they're still independent events. Independent probability. Let's go into this a little more. You're playing a fantasy board game with a 20-sided die. You need to roll a 20 to get a critical hit. What are the odds of doing so? What would be the percentage chance? The probability? How about twice in a row? You may recognize that die if you or a friend or loved one or unloved one or husband or wife or mistress played Dungeons and Dragons or a related game. Now, how about twice in a row? Okay, I'm going to give you a moment to answer that question. You can press space bar or tap your screen to pause. I'll give you a moment to do that. Okay, we're back. So there are 20 sides. You need a 20, and there's a 1 in 20 chance of that. You can divide 1 by 20. We're using your knowledge of factors, percentages, and 100. Try to get the denominator to 100 and make it a percentage. Let's try that. So 1 over 20 times 5 over 5 equals 5 over 100 equals 5%, or P equals 0.05. How about twice? So that's 1 over 20 times 1 over 20, which is equal to 1 over 400, or 0.25%, or P equals 0.0025. Because remember, to change from a percent to a decimal, we move the decimal point over 2 places. Okay? And you may also know off the top of your head, 1 over 20 equals 5%. It's good to know some of these fractions off the top of your head. Very handy. 1 over 20 is 5%. Okay? So how many total combinations are there? Let's get back to coins. Are there if we're flipping 2 coins? So take a moment. You can grab some coins if you want and figure this out. But how many total combinations are there if we're flipping 2 coins? How many do you think? I'll give you 1 moment to pause. Okay, we're back. If you're having problems, remember you can write a chart on your whiteboard or scrap paper. So let's look at the total combinations. I wrote out a chart here. Coin 1, coin 2. Coin 1 comes up heads, coin 2 comes up heads. They both come up the same. Coin 1 comes up heads, coin 2 comes up tails. Coin 1 comes up tails, coin 2 comes up tails. Coin 1 comes up tails, coin 2 comes up heads. So that's every possibility. You could flip them around to check, but that comes out to a total of 4 combinations. Now, you could also figure that out by multiplying, because there's 2 sides to a coin, right? And there's 2 coins. 2 times 2 is 4. Okay, and that's it for this lecture. I'll see you next time with more on probability.